Hello. Uh, Last week we went on a journey, starting with the most ancient form of man all the way up to the 1960s. This week's journey will somehow be even stranger than last. And we're going to be doing it memento style. And by that I mean we're going backwards and it's going to be full of twists and surprises. Today we're going to go over numeral systems with the goal of discussing binary numbers. And by the end of the week, we will end up somewhere truly unexpected. Right now, talk about numbers using a decimal system with 10 digits 0, 1, 2, 3, and the rest of them. The decimal system has some nice advantages to it. Multiplying by 10 is nice and easy, you just kind of move the thing over. We also commonly encounter what's known as a sexagesimal numeral system, which uses 60 as its base. This is, of course, the way we keep time and use clocks. And 60 is a nice, neat number to do math with. You can divide it by 2, 3, 4, 5, and 6, and you get a whole number every single time. You might also be familiar with like Roman numerals or maybe even like Egyptian numbers. Different civilizations represent numbers in different ways. And as we've discussed before, mathematics as we know it now is very globally standardized, but back in the day, people did math in different ways and they used different symbols and different notations. But the decimal system we use now won out and got globally adopted. Its exact time of invention is not known, but it is likely sometime between the 1st and 4th century in India. And then, in the 9th century, it spread to the rest of the world via the great Arabic mathematician al-Khwarizmi through his seminal text, al-Jabr, which formalized and invented a whole lot of mathematics. His legacy lives on whether we know it or not. The word algorithm stemmed from translations of his name, and the word algebra is named after his great work. As the notation was invented in India, but popularized by the Arabic world, we refer to them as Hindu Arabic numerals. And it won out because it was an awfully good notation to use. It was designed with complex calculations in mind. And if you had to learn Roman numerals in school and were made to try to do math with them, you can see pretty clearly why the base 10 Hindu Arabic numeral system won out. And there is one other explanation for the base 10 numerals, and it's these puppies. Humans typically having 10 fingers. And of course, as we all know, it's a natural human instinct to count on those fingers, meaning that the base 10 numerals have a deep intuitiveness and in some ways, an unfair advantage compared to other numeral systems. So here's an out of the blue question. If base 10 numbers are so great, why don't computers use them? Computers, as you likely know, use binary numbers. If you watch a cartoon that has a robot in it, you'll see the zeros and the ones. Yeah. Binary numbers are also known as base 2 numbers, meaning that there are only two units or types of things we use to represent numbers in this notation. Our decimal system has 10 symbols, 0 through 9, but binary systems only have two, and those two symbols that we like to use are zeros and ones. So back to the question from earlier, binary notation is the preference for computing, and I can tell you why. It is easier for a computer to differentiate between two distinct states, much easier than it is to differentiate between 10 states. And this was especially true back in the early days of computing. And it remains the standard we use today, and is the foundation of all of the technology that we are so familiar with and accustomed to. You may find it interesting to know that long before the first computers, mathematicians had already mapped out how binary numbers would work. Before they were even imagining computations and mechanization, certain mathematicians were getting deep into binary numbers. These mathematicians were in different parts of the world and lived hundreds of years apart. Yet somehow, they all had the same reason for wanting to learn about binary numbers. They did not see them as a replacement for the base 10 numbers people were already familiar with. These mathematicians all independently came to the conclusion that binary numbers were a secret key, a key that would bridge theology, philosophy, and mathematics together. That's all for today's video. I'll see you tomorrow.